Hello everyone. Today we will explain 7.9 more lenses in action. In the previous lesson, as if you remember, we talked about lenses. We took an example lenses in a telescope, how it works. So here we will see more uses of lenses, or how do we use lenses in our daily life. Firstly, the first example is camera. As you know, camera, it consists of or it has a lens. Okay, these lenses, we have different cameras. These cameras, they differ from each other by the lenses. Okay, by some features of the lenses. But the principle of camera, how it works. The principle is as it's shown in this drawing. Here, what do you have? Object. This object will send rays. This rays, when it enters the camera, it enters through a lens. Okay, so this camera, it uses convex lens. Okay, the kind of lenses in camera are convex lenses. Okay, so what will happen? As we explained before, in convex lens, when the light it passes through it, it will converge, or it will meet in a point. Okay, here it's the light or the rays will bend until it will meet at a point. So here what is happening, the light, okay, when the light it passes through the lens, it will converge and it will meet at a specific point. So this uses a convex lens to form a small inverted real image. So the kind of image that it will be formed in camera, it's what? It's a small inverted and real image. This small inverted real image, it will be formed on a sensor. Okay, before in old cameras they were using a film. Okay, but nowadays they are not using that kind of cameras. They are using the cameras that it has sensors. Okay, the sensor here they are light sensors. Okay, so the image sensor, it has this, it's the image sensor. Okay, is a light sensitive microchip containing millions of microscopic solar cells. So light, it passes through it, it will be received by this light sensor. Then this light sensor, it convert it into electric charge. Then this electric charge, you can convert it into a image. Here, how it works now, when the shutter opens, this captures the image as a pattern of electric charge, which can be stored as data on a memory card. So here it's the first uses of convex lenses. The second one, the human eye. The human eye, the principle of how our eyes it works is the same as the principle of cameras. How's that? Also here, what do we have? We have an object, it sends light. This light, when it will pass through the eye, firstly it will pass through the cornea and the watery liquid. This cornea and watery liquid, what they will do, they will converge the light. Okay, so the light is mainly converged by the cornea and the watery liquid behind it. Then after cornea and watery liquid, what we will have, we have here the lens. Okay, so then the lens is flexible, which it's used to make focusing adjustment. Okay, its shape is changed by a ring of muscles. After that, when the light, it will pass the cornea, watery liquid and the lens, then the light will be focused on a specific point on the retina. Then this retina, it has millions of light sensitive cells. Okay, these light sensitive cells will detect the light and will send it as a signal to the brain through the optic nerve. Again, light or any object will send light. This light, it passes firstly through the cornea and watery liquid. Cornea and watery liquid, they will converge, or they will try to keep it, or to make the rays meet at specific point. Then it will pass through the lens. Then this lens, it will focus the rays on specific point, okay, on retina. Retina, it has millions of light sensitive cells. The function of this light sensitive cells, it's to detect the light and convert it into a signal to be sent to the brain through the optic nerve. The projector. The projector, also the principle of it, it's what it makes. It uses lenses, and these lenses, it makes images. But how it will be the image that it's produced or formed by the projector? The projector, it will use convex lens. This convex lens, they call it projection lens. It makes, or it will form a large inverted real image. So what are the features of the image that it will be formed by projection lens? Okay, by this projection lens, it's large, inverted, and real image. This image, it will be formed on a screen. Okay, now how it works, or the principle of it is what? So if you look at here, you will see, what do we have? We have a lamp, we have a LCD panel, and then we have the projection lens. For the projected image to be upright, okay, because here we said the image, it will be inverted. So inside here, it's inverted, but when it's on a screen, no, it's upright. Okay, how? What happened, or how we can make it upward? So for the projected image to be upward, the picture on the panel must be upside down. So as you can see here this is the LCD panel, okay, or they call it liquid crystal display. The image here, they show it as, or the image here, it will be upside down. Because it's upside down, when the light, it pass through it, when it will pass through the projection lens, it will invert it. So when it will invert it, now it will be shown here as a upward image. Then how the image will be large? The answer for this one, or if you want to understand it, if you will go back to the last lesson, in the questions, it was how you can make the image larger. Okay, so if you remember, I said you will have lens and you will have principal focus. If the object, now the LCD panel, it represents the object. If the object, to make it larger than, to make the image of it, to make it larger, so we will put the object where? We will put it outside the principal focus. So here, this is the lens, and here it's the principal focus. Okay, so where is the object now? It's outside the principal focus. So for a large image, the panel has to be just outside of the principal focus of the projection lens. Then last thing, to make focusing adjustment, the lens is moved backward and forward. Here what will happen, this you can just adjust it by removing it backward or forward until you will get a clear image. Or what do you mean by clear image here? It means all these rays, it will meet on a specific point on the screen. So here it's how the projector it works. TV projection systems. How the TV it works. Maybe you heard about something we call it pixels. Okay, the TV screen, if you will focus on it, you will see it consists of millions of tiny cells or small like squares. Okay, these squares, each square we call it a pixel. So in TV projection system, how it works, the picture is created by making millions of tiny cells called pixels light up in different combination of shade and color. What's that mean? When you turn on the TV, the electricity or the charge of the electricity, it makes the pixels light up. Behind these pixels, there is what? There is, we call it LCD panel. This LCD panel, it consists of, there are three LCD panels. These three panels, they are what? They are three different panels with different colors. One, it has red color, another one green, another one blue. So what will happen, these three panels, okay, it will light in a specific combination. Okay, so what you see on the screen is an overlapping combination of the three images in different colors. Okay, so these three colors of LCD panel, what will happen, they will light up in a specific combination. Okay, then this lightening up or this combination, it makes or it shows the image. Then this image, it will be shown on the pixels of the screen. Next one, cinema projection systems. As you know, the cinema of these days, it differ from the cinema of like the cinema that they were using long time ago. Before, it was what? It was a film. Okay, this film, there will be a light, it passed through it. Then this, when light it passed through it, it goes to a lens, and this lens, it will make it the image larger on a screen. But nowadays, what they use digital projection system, which it's similar to the TV. Okay, it's the same principle. There is like pixels, these pixels, and there is LCD. This the panels, the LCD panels. These panels, it has the three colors. Okay, the red, green, blue. They light up in a specific combination, and then it shows the image on a screen. Questions. You will need information from the previous spreads 7.7 and 7.8 on how and where a convex lens forms an image. Question number 1. In most cameras, the lens can be moved in and out to make focusing adjustments. If the camera on the opposite page is to take a picture of an object about meter in front of it, will the lens need to be moved closer to the sensor or further away? Let's go back to the page. Here, this camera. Now, as you can see here, because the object is far from the lens, okay, so here the sensor and the lens, they are close to each other. But if this object will change its place, okay, for example, let's say we have an object, it's here. So now what change happened? The change that it will happen, it's the size of the object, because the distance now from object to the lens, it's close or it's short. So what will happen? The object now, of course, it looks larger. Now because it's larger, so it will not show clearly on the sensor. So what should happen? This lens, it should move farther from the sensor. So in this case, or in this state, what will happen when the lens will move farther? Okay, so the image, it will show clearly here, and it will fit to the sensory here. Question number 2. Compared with a camera, what difference is there in the way the human eye makes focusing adjustment? If we will come back here to the eye, you will see in our eye we don't have a lens that it can move backward and or forward. Okay, instead of that, what do we have? We have this lens, but what will happen to this lens? It will change its thickness. So it will change to its thickness. So sometimes it will be thicker, sometimes it will be thinner. So by changing the thickness of it, this is another way of adjusting the, it's like adjusting the lens and making the image clear. Question number 3. In the projector at the top of this page, if the lens is moved slightly further from the LCD panel, where must the screen be moved for the image on the screen to remain in focus? Closer to the projector or further? So here what is happening, this question is just opposite to the question number 1. Here what will happen? The question, it says if this lens will be moved here further from the LCD panel. Okay, so what is happening, this distance, it's changing, it's being more. If this, it will be more, so this, it will affect on the other side. Here, if it will be, the distance will be more, so here it should be less. So now if the lens, it moved further to this direction, okay, now to keep the image clear, what we should do to the screen here, we should move to the opposite direction. What's the meaning of opposite direction? It means it should be closer to the lens. It's exactly opposite to this way, okay, to this question. Here what happened? The object, it gets closer to the lens. So what we should do here, we should keep it further. So that was everything for this lesson. I hope everything was clear. And again, please don't forget to write your name once you will finish watching the video. If you have any questions, concerns, please don't hesitate to text me. Thank you and have a good day.